Today we're doing medium problem 10-11 capacity to ship packages within D days. So if packages weights are each day below the ship with packages in order given by weights, manual model, then the maximum weight capacity of the ship, least weight capacity of the ship that will result in all packages on the code being shipped within days. Okay. So I guess we want to partition this such that into, I mean, technically we could do in 4 days, but let's say we want to partition it into this many subarrays. Is days is less than or equal to length. Okay, so you want to partition this weights into days subarray such that maximum is minimized, which is a classic problem which I think might be solvable in linear time. But what we can do is, when we don't know what's condition for binary search, until so answer to some question is monotonous, so it's true for and then false for everything, or false and from some point true for everything. What is the question here? Given some capacity, can we do it in this many days, right? Are the answers monotonous? Well, if we can do it with capacity 10, we can do it with capacity 11, 12, 14, whatever. So boom, we got binary search on the maximum capacity. So what we can do is, I mean, question is what's the max capacity, because theoretically it could be 1 day, and so it's like max weights times weights, or it's just sum of weights, so 1 sum weights L is under R. Now we can do like current shipments for weight in weights if current plus weight over M, then yeah, that sucks. If weight over M, then we do like can't is true, can't is false, right? Shipment, what? Current, can't. Okay, that's just a condition, because right here, if I go over what I want to do, that's a new shipment. So shipments plus equals 1 and current is weight, and if weight would be over that, then that wouldn't work, right? And then finally we do like and then if what we want to do, that's so shipments over days or can't, then we want to increase the weight for sure, otherwise it's possible, so the M might be the answer. What the hell? Okay. Let's see. Not sure you can really do that, to be honest. Yeah, I'm not adding the weight here. Okay, that works. I was surprised because I thought the logic is bulletproof. Okay, should pass. We are at the lower end, so might be not optimal. Binary search. Okay, fair enough. Okay, follow-up question. In any order, not necessarily sequentially as given. Might be AI, but let's consider it. So, follow-up question. What if you were allowed to choose weights in any order, not necessarily sequentially as given in the main question? How would you solve this problem? That's interesting. Weights in any order. Oh. Interesting. Okay. Not sure how, because I mean you just want to split elements into k bins, right? Then we what? I have no clue, mate. You have to be kidding me, that's crazy. I don't know. Anyways, let's just write editorial and eat. And I really need to sleep, bro, because today even my hamstring gave out, and that hasn't happened in like I don't even know how long, so it's not good. What question to ask for binary search? Okay, so can we use, or like, okay, so if we can ship within days, if we can ship all the weights within days with maximum ship weight limit L, we can also do it with maximum ship L plus 1, L plus 2, whatever, right? You guessed. And similarly, if we can't make it work with limit L, we can't make it work with lower limits. You guessed it binary search. Theoretically, okay, so maximum capacity might need to be some weights if there is one, therefore the bounds of the search are 0 v vn, where and a constant 500 and n is the number of weights. Then in each iteration we just greedily check the number of shipments necessary for with a given limit. And log nv, since we do log nv iterations and each takes on space complexity on, since we only use a couple of extra variables. It's probably the most repeated sentence of my editorials. Okay, bye.